Hey, welcome back to Squid. In this video, we'll be looking at 9 questions on MathSpace on how to calculate the gradient of a line. So let's just jump into the program. Okay, question 1 reads as follows. Consider the interval shown in the graph from point A, -4 to 4, and then point B from -3, 8. So what we're going to do is part A, we're going to find the rise, changing the y value between points A and B, and note, we're going to ensure that the signs are correct. So we're going to be looking at whether the gradient is either positive or negative. So let's have a look at this graph then. We've got the, can I zoom in? No, I can't zoom in. So we've got the point A, which is, let's just write it down, -4 to 4, and we've got the point B, which is -3 to 8. What we need to do is find the rise and the run, okay? So the rise over run is what we call the gradient, okay? The gradient. And the rise is the change, okay? The change in the y values, and the run is a change in the x values. So what we can do is we can label this our x1 and y1, and then the coordinate B, we can say, or the point B, we can say x2 and y2. So what we can do then is we can do y2 minus y1, and that's going to give us our rise. We can calculate our rise by doing that. Here we go. That's my y2, that's my y1. I've got 8 minus 4, so 8 minus 4 gives us a rise of 4 units. Okay, so we can put that into here now. We can say, hey, our rise is going to be 4. Let's see what we get. Yep, perfect. And then it says find the run, just changing the x value between the points A and B. Note that we want to have the correct sign. Okay, so again, looking at our run now, the change in the x value. So x1 is -4 and x2 is -3. So we can do the change in the run, or the change in the x, is going to be x2 minus x1. So we've got -3 minus, and we've got a -4. So we've got -3 plus 4. That gives us a change in the x value of 1. Okay, we've got a change of 1. Actually, if you look over here at the graph, look, this point here is our x2, or that's x1 and x2. There is a difference of 1 unit. Okay, that's 1 units. That's 1 unit difference. So let's plug that into here. We can just write here 1 and see what that gives us. Brilliant. Okay, that's correct. Now we're going to go into part C. Part C says find the gradient of the interval AB. So find the gradient of the interval AB. Now remember, gradient is simply the rise over the run. And we've already worked it out, haven't we? We've got the change in the y value, which was 4, and the change in the x value, which was the run, which was, what was it? It was 1, wasn't it? So our gradient, okay, our gradient is 4/1, which simply is just the value 4, okay? So we have a gradient of 4 between the interval A and B. So let's type in here 4, and let's just check whether this is right. Excellent. Okay, so we're going to continue on to question 2. Question 2 then says, consider the line below where point A is 2, 0 and point B is 0, 8. And it says, which both lie on the line, and then it says calculate the gradient for this line. Okay, so what is the gradient of the line? Again, we're just going to use the gradient formula. So we're going to type in here gradient, okay, is equal to the rise over the run, which is the difference in the y value over the difference in the x value. Okay, in other words, we can say y2 minus y1 over x2 minus x1. That's what we're doing to find out the gradient. So we've got our points. We've got A, which is 2, 0, and we've got B, which is 0, 8. Okay, we're just going to find out the difference here. First thing first, let's just label these. I'll call it x1 and y1, and then x2 and y2. So I'm going to substitute those values, okay, these values into the equation, or the gradient formula, to see what we get. So we've got 8 minus 0 divided by 0 minus 2, okay, and that gives us a value of 8 over minus 2. If you simplify that, you get minus 4. Okay, it's negative. It's very important to keep the sign with the gradient. It's negative because if you look at this line from left to right, okay, from left to right, this line's actually going down. Okay, it has a negative gradient. So our value here for the gradient is minus 4. So let's just put that in here, minus 4. Okay, good, excellent. Let's clear this up because it's a bit messy here, and let's see what the next question is. Part B says, as x increases, is the value of y increasing or decreasing? So let's have a look at this then. As x, this is my x value, as x increases, so from here it goes 5, that goes to 10, is the value of y, this is my y value, okay? This axis here is my y value. So as x increases, does y increase or decrease? Well, if you look at this, as x is increasing, y is decreasing, okay? So as x increases, the value of y decreases. Let's submit that. Excellent. We're going to continue on to question 3. If at any point you feel I'm going too fast, then just pause the video and check that your task is, you're on the same question in your task. Okay. So part 3, we have the question, what is the gradient of the line shown given from the points A, which is 4, 0, and point B, 0, 1, that lie on the line. So again, we just use the gradient formula. This is the third time we're using that formula. So y2 minus y1 over x2 minus x1. Pause the video and see if you can just do this for yourself. These are the points. Point A is 4, 0, and B is going to be 0, 1. Just see if you can do that for yourself. Okay, when you're ready, just play the video and I'll work it through. So we have, well, first thing first, let's just label these x1, y1, x2 and y2, and we're going to substitute 1 minus 0 divided by 0 minus 4. So we end up getting 1 divided by minus 4, and we get a gradient of negative 1/4. Again, look from left to right. You can see that this line is going down. Okay, since the line is going down, it means that you have a negative gradient. Okay, so we have a gradient of negative 1/4. So let's put that here, minus 1/4, and check if that's right. Yeah, good. Let's continue on to question 4 then. Question 4, it says, which of the following pairs of coordinates will have a gradient that is undefined? Now, okay, a gradient that is undefined. Now, we can have a gradient that is going from left to right. Yeah, we can have a gradient that is going up, okay? That is a positive gradient. Okay, so anything like, you know, 1/4 or 2 or, you know, maybe even 17 or whatever. And then from left to right, you can have a gradient that's going down, okay, which is a negative gradient. Okay, so any number that is negative, minus 1/4 we had, you could have minus 2, minus 4, whatever other number. And then you could have something that is a flat line, okay? The rise over the run is equal to 0. Okay, because it's a flat line, you don't have a positive gradient nor a negative gradient. You just have a flat line. You have a 0 gradient. The ones that are undefined are the lines that are vertical. Okay, a line that's going either directly up or down is has a gradient. Okay, that is undefined. Okay, so we have a gradient equal to undefined. We have an undefined gradient. So we're looking for something here that has. In fact, if I draw a grid here, so in fact, if we look at this on a graph, a line that has a gradient which is undefined will be a vertical line going straight. In this example, the value of x will be constant, okay? X will be some value that will always be constant. So for example, here it might be x equals 3. No matter where I go up or down on this line, whether I choose that point or that point or that point, no matter where I go up and down this line, the x value is always going to be equal to that same constant, which in this case is 3, okay? So if we have a constant x value, we know that we have a line that is vertical, that is straight, going straight up or straight down, in which case it would have a gradient that is undefined, okay? So any line that is vertical, okay, i.e. the x coordinate, okay, the x value is constant, we have a gradient which is undefined. So let's look at something that, out of the examples, let's look which ones have an x value which is constant. So that's my x, my x. I'm looking for an x value that is constant, okay? So that's minus 10 and minus 10. So this is going to be one of our options because that's constant, okay? So it's going to have a gradient which is undefined. This is also constant. So that's going to be a gradient which is undefined. This is not, you see that is not constant, so that is not undefined. And then the last one, oh, that is also not constant, so it's not defined, okay? Basically, it has a gradient, either positive or negative or zero. So we can confirm this by substituting these values into the gradient formula, okay? At this point, I think just point and make a note that if the x value is constant, we have a gradient which is undefined. But let's just double check that using the gradient formula. So pause if you want to, because I'm going to clear this out, and then I'm going to check. Let's call this A and B using, or it is A and B, A there and B there. Let's just check that this is actually undefined, okay? So I have, let's label these x1, y1, x2, and y2, okay? So we're going to do 10 minus 2 over minus 10 minus 10, okay? So why am I doing minus? Because the formula is y2 minus y1 divided by x2 minus x1. This just happened to be a negative value, so we're doing minus 10. So 10 minus 2 is 8, and then minus 10 plus 10 is 0. And because we can't divide by 0, we have a gradient which is undefined, okay? We have an undefined gradient. So that is correct. This is, in fact, a line, a vertical line, which has a gradient which is undefined. So let's go ahead and say that we're going to select A and B and submit our answer. Excellent. So we're going to continue on to question 5 now. So question 5 says, find the gradient of the line that passes through the point A, which is -1, 0, and point B, which is 0, 2. And it says using m is equal to rise over run. So we know this anyway. We're quite familiar with this now. So rise over run, we're going to do y2 minus y1 over x2 minus x1, which is the difference in the y value over the difference in the x value, which is the rise over run. So let's quickly do this then. Remember, best practice is to label your coordinates, x1 and what y doesn't want me to write up here. Okay, x2 and y2. Right, okay. So let's substitute these values into the gradient formula and see what we get. We get 2 minus 0 divided by 0 minus -1. Be careful of the signs. Okay, here you can see it says minus a -1. So let's see what we do. Let's see what we get then. We've got 2 minus 0 is 2, and then 0 minus a -1 is 1. We end up getting a gradient of 2. Okay, here a negative and a negative make a positive. So we get a gradient of 2. M is equal to 2. Using rise over run. Maybe they don't want us to write down 2. Maybe they want us to write down 2 over 1. Anyway, let's just check. Yeah, it's correct. Let's just skip ahead and see if we get a different question. Oh, here we go. Look, question 8. Right. Question 8 says, a line passes through the point 12, c and -4, 24 and has a gradient of -7 over 4. Find the value of c. Let's just label these x1 and y1, x2 and y2. We already have our gradient, which is -7 over 4. Let's substitute these values into the formula. So we get 24 minus c divided by -4 minus 12. And this should equal to a -7 over 4. Okay, so -4 minus 12 is -16, and we've still got 24 minus c, and this is equal to -7 over 4. Okay, what we'll do now is we'll take this and we'll multiply both sides by -16. Okay, so multiply this by -16. That will cancel that out. We end up getting 24 minus c is equal to -7 over 4 times by -16. Now we can simplify this. How many 4 is going to 4? 1. How many 4 is going to 16 is 4. So we end up getting -7 times -4 is 28. And we get 24 minus c is equal to 28. So if we minus the 24 here, minus the 24 here, we end up getting a value of 4. 28 minus 24 is 4. So minus c is equal to 4. Therefore, c is equal to -4. C is equal to -4. Let's substitute that into our answer. C is equal to -4. Good, excellent. So let's continue on to question 9. Here we go. Look, here's another question. It says, two lines, line 1 and line 2, have equations y is equal to -x plus 2 and y is equal to x plus 8 respectively. The lines and their points of intersection have been graphed. What's the question then? When x is equal to -3, find the y coordinate for the corresponding point on line 1. Okay, so line 1 has the equation y is equal to -x plus 2. And they told us that when x is equal to -3, so when x is equal to -3, find the y value. So we're just going to substitute the value of x into the equation to see what we get for y. So we want to do this. We can do y is equal to minus, we have a -3 plus 2 minus -3 is 3 plus 2. So we end up getting a y value of 5. Let's look if that is the case. Okay, so we have a coordinate of -3, 5. Let's look on the graph. -3, when x equals to -3, 1, 2, 3, we end up getting a y value of 5. So when x is -3, so that is correct. I can confirm that that is correct from the graph. So let's put that value in then. We get y is equal to 5. Something broke. Your latest action will not have been saved. MathSpace crashed. Something's gone wrong. I need to start again. Make sure you subscribe. I will be uploading a part 2 to this just so I can go over that question. And as always, I'll see you in the next one.